My name is Borna Müller. I'm an epidemiologist in Roche in a department called Global Access. So maybe just a few words. What is an epidemiologist? Essentially, I would say an epidemiologist studies the natural history of diseases, sort of on a population level. So what we're interested in is to understand how do external factors, how do patient-related factors, and how do disease-related factors somehow interact and then lead to a sort of a manifestation of the disease. So a nice example of an epidemiological study would be to see whether actually smoking can cause lung cancer, how to actually get rid of Ebola. These things like this are actually epidemiological studies. Global Access in Roche is actually a department concerned with patient access, ensuring that theoretically patients get access to the drugs if they need it. It doesn't necessarily have to be Roche drugs, but conceptually whether the health system is able to identify patients that would theoretically need a specific drug and actually also deliver it. That in the Western, let's say in the Western world, the main issue there in terms of access might be actually insurances, reimbursement of specific drugs around insurances. But when you look into low middle income countries, which is sort of the area where I'm more working on, then it's really going more towards public health and looking at the health system's capacity, whether a health system is actually able to identify patients and deliver appropriate treatment. So I'm going to talk a bit more about the connection of epidemiology and access in my examples. But without any further ado, let me jump into this. So first we're talking about data. So this is a terrible slide because it's like kind of random how I chose the topics that I represented on it. But essentially I just wanted to highlight that there is so much data in pharma. Pharma is really like everything is full of data. And I mean it's a little bit arbitrary. Not arbitrary because I work in this space, but essentially I'm focusing on this. But I think most of the people are aware of the principal steps in the development of drugs. So first you do basic research, you identify molecules, maybe toxicity testing, then you do clinical trials, clinical development, and then you have a regulatory submission where you actually deliver your evidence, and then essentially the regulator, FDA, EMA will say, okay, we give you market authorization, this drug works and has an acceptable safety profile. And all of this is full of data, obviously, but I just wanted to show that there's more. There's much more data. Obviously, there is marketing. We're actually obliged to do safety recording, so to look at what are side effects that are sort of reported in connection with the administration of specific drugs. There's medical information that needs to be provided, so this is like by law. And then there are other topics as well. So I'm not going to go into the details here, but I just wanted to highlight 3 points. This is essentially where I'm from. So if you talk to other Roche people, they might do different data visualization, maybe much better than us, but I'm not aware of that because it's a universe. I'm only aware of these 3 dots. And essentially what these represent is real-world evidence. So real-world evidence is a really big topic now. If you want to know the buzzwords in pharma, those are the buzzwords: real-world evidence, access, and personalized healthcare. If you apply for, you just randomly tell them. So real-world evidence essentially is now looking at what's the reality now. How does the drug work? What's the effectiveness of the drug in the real life situation versus a not completely, but somewhat artificial situation of a clinical trial where you have a very selected population of patients. So more and more people are looking into real-world evidence. It's also more and more demanded, especially from insurers. They want to see whether it's actually worthwhile really investing or paying for specific drugs. The other one is access. Access I already explained, I think, more or less. And then PHC, personalized healthcare, or it's also called precision medicine, sometimes in other companies. So these are broadly the topics that I'm going to talk about. So this is the data that I'm referring to. So now data visualization. What is this? Why do we do data visualization there? And first, I think I should say that we're doing really poorly, really terrible. I think you're going to be very disappointed about my visualizations. And the reason for that is essentially, there's two reasons right now why we do data visualization. Primarily it's for communication purposes. So it's complex information, you want to make it, pictures are sort of a universal language. You want people to understand it, so you visualize it somehow. But it's kind of, it's not like a must-have, right? But it works much better if you communicate in a more appealing way. I think there's another one which I find relative to that at least as important, if not more important. Actually, we need to visualize data to analyze the data. What I mean by this is sometimes there's kind of data and the complexity of data doesn't allow you to understand it unless you visualize. So many of the findings I think couldn't be made unless you visualize the data. And I think, personally, I think there are two reasons for that. I think human species is a very visual species. So we look at things, we try to look at things. And the second one is we have a great ability in pattern recognition. Human species is really good in pattern recognition, especially visual pattern recognition. And I think that maybe sometimes we actually need the visual to recognize the patterns. And I'm actually going to focus on this piece here. So I'm just going to go through 3 examples. I think 3, I have a few more, but I think I will focus on 3 to highlight this. So as I said, it's going to look dreadful, but it's hopefully going to show you that you need to visualize to understand the data. Okay, first example. First example is multiple sclerosis. And the question that was posed is, how much multiple sclerosis is there in the Middle East? And most of the data, when you're going to literature, published literature, is a registry data, disease registry data coming maybe from health clinics that sort of compile the data and then telling you, okay, relative to the population we have this many cases, so then you can calculate rates, etc., and come up with an estimate. How much is there on a nationwide scale? How much multiple sclerosis? And each of these dots represents one registry. And each of these dots is from the same country, Iran. Iran has probably the best data availability in terms of multiple sclerosis. But what it also shows is a big blob. I don't know how much MS there is in Iran, because look, even in 1 year, 2011, you can see from about 5 per 100,000 people to up to 80 per 100,000. So how much MS is there in Iran, right? So how people generally interpreted such a picture was, well, it's variable. Maybe there are epidemiological factors, behavioral factors that affect this. And the second, even more often raised concern is that the data is actually wrong. So let's do another study. And then maybe we get another dot and then wonder whether this dot is better than the rest. What I didn't tell you about this picture is that the different marker types, they represent different provinces of Iran. So all of these crosses, they're from the same province, essentially same registry, as well as the squares and these other ones. And also, these markers here represent actually a registry from an area that is most affluent, economically more advanced than other areas. You can already see that that's Isfahan and Tehran province, that these areas, they actually align quite well relative to the others. So this sparked the hypothesis, maybe this variability isn't due to epidemiological factors, or maybe the data isn't flawed, but actually in economically advanced settings, the ability to diagnose patients is better, while here it's maybe worse. And then what I did was just looking at other data in the region from other countries, and essentially trying to see, how does it relate to this? And then if you look at other data from other countries. These are generally also more affluent countries. If there's data available, generally they would be more affluent. And they also have longitudinal data, and what you can see is actually they all align. So now what I superimposed here is data from Qatar, the purple one is Turkey, then I think Jordan, UAE somewhere, this is Kuwait. So now if you look at the more affluent provinces in Iran and these richer countries, then you actually see consistency. So it's probably not flawed. It's probably not so much the epidemiological differences. Maybe it's really, our hypothesis is true, that the ability to diagnose is driving the variability. So this is what we came up with. There's actually high consistency among affluent regions. We think that this is related to ability to diagnose. And even this increase, this massive increase that you can see is probably best explained through a changing diagnosis rate, because actually treatments in the Middle East became available after the millennium, and also the diagnostic means to actually identify MS properly became available here. So what this graph is depicting is that presumably this is the prevalence of MS. This is how much is diagnosed in the very advanced regions, and you can see over time how the diagnosis rate is increasing, and then you can also see that in other regions this diagnosis is not happening. Now, okay, long story short, what I want to say is unless I do a visualization, I cannot actually understand that. And also I can't communicate it. Like most of the times if I have to communicate this to marketing people or others that are not so savvy around epidemiological factors, they need the visualization to understand this issue. Okay, I think that's example number one. This outlier is a sort of a different study design, and that explains it. I wanted to show to you another, and then I have a few more, and then you can choose which one you want. No, I'm just going to impose some. So this is another disease, Hemophilia A. It's a blood disorder, so it's a genetic disorder. Patients with Hemophilia A, they lack clotting factor 8, and then they bleed, and bleeding can't be really controlled. So these patients generally receive clotting factor 8 to actually stop the bleeding. The question here was, what's the problem with treatment of hemophilia globally? How can we address it globally? And you can think that there's a wide spectrum of problems, right? There might be countries that actually diagnose and identify patients quite well, but maybe they don't have enough money. They have a money issue, but otherwise the health system issues. On the other end of the spectrum, we have completely dysfunctional health systems, where they're not going to be able to diagnose, they're not going to be able to treat, they don't have money. But what's happening in between? So what's the spectrum, and how do we address, what are the main issues, and how do we address these issues? Like, how can we archetype the issues within that spectrum? And that was the sort of the question at the start of this particular analysis. I'm not going to go into the detail, but essentially what you see here on the y-axis is the percentage of underreporting. In other words, what we tried to do here, each dot represents a country. What we tried to do here was to actually extrapolate how much hemophilia A would we expect in each country globally, using certain extrapolations and modeling approaches. And then we looked at how much is reported in these countries. And essentially this line is sort of the threshold that we shows, which indicates that all the countries lying below report much less hemophilia than we would expect based on our model. So our model would say there's much more, but they don't report much less. So everything below this probably has a diagnosis issue. What you can see on the x-axis is the availability of treatment. I mentioned factor 8 as a sort of a replacement factor that you need to give to these patients, and there's like global guidelines in terms of how much factor 8 needs to be available in a country to be able to support these patients. There's global guidelines. So essentially what these say is that if you have this much factor 8, you can actually look up this data. You can look at how much factor VIII did the country purchase. And then if you look at these guidelines, you can see that in some countries they have very little factor VIII availability per patient reported. This is very poor availability of the drug. This is an intermediate availability, and this is a good availability. So essentially, in this quadrant, countries in this quadrant, they diagnose everyone and they treat them well. Here it's like intermediate treatment, but they diagnose them. Here they diagnose well, but treatment is poor, and here it's actually both poor. Now there's a third dimension. Third dimension that was relevant to archetype globally, the problem of access was affordability. Can these, now they perform this or that way, but can they pay for better performance? And what we introduced here was actually sort of, it's quite correlated with the Human Development Index, 4 groups of affordability. So group 1 is highest affordability, second highest, sort of below median, and then poor affordability. These countries don't have money to pay. Low health development index. And it's not surprising that the ones that really perform well in all aspects are actually the ones with high affordability. And it's also not surprising that most of the one in group 4 with very poor affordability are here, where the health system seems to be dysfunctional. But this archetyping, this visualization helped the team to understand the issues in 3 dimensions. So you could see, for instance, there are some countries with very poor performance in terms of treatment and diagnosis with a high affordability. These are rich countries that seem to underestimate the problem. This is generally Middle East. Qatar is one of these. They have lots of money, but they don't do much for this particular disease. But you also find some that perform really well, but they have issues with money. So naturally, when you want to improve access of patients in these settings, you would have to have tailored solutions. So this is sort of helping to archetype. And essentially what this is showing is like a 3-dimensional problem, graphical depiction, and trying to explain it again to others. So you can see these, broadly you can see these larger archetypes. High affordability, adequate diagnosis, medium affordability, adequate diagnosis, different levels of affordability, CMS here, poor to very poor treatment, and so on. So we talked about that. Maybe, I don't know, Ye can think of a better way to visualize. But I just want to show you why we're actually doing visualization, what we're needing them for. Essentially is to understand the issue and to communicate the issue. I don't think without any visualization I would have been able to actually archetype access issues globally for hemophilia. I hope you can appreciate that. There's a nice bubble plot I'm not going to talk about. This one is also very chaotic and nice. How's the time thing?
Good.
Good.
Yeah, 18 minutes. You have some.
18 minutes? Nice. Okay, so this one I chose because it's a nicer picture. I didn't want to have to look too bad. This is actually, it's our Shiny, our Shiny platform. And what it shows is looking at chronic lymphatic leukemia and essentially the patient treatment pathways. Chronic lymphatic leukemia is a type of leukemia that appears very late in life. Patients usually are diagnosed at a very advanced age. And very often you don't have to do anything. They're sort of in a watch and wait situation. And many patients die with the disease, but not of the disease. So then they don't receive treatment. But some with symptoms that are sort of severe or require management, they receive first line of therapy. So this visualization, what it shows is sort of the relative proportion of these patients. And then it shows you if symptoms deteriorate, what is going to happen to these patients in terms of the treatment. What are they going to receive? This group of treatment, or that, or that, or that. And then later on, they may advance further. Then they receive this, and that shows you the relative contribution in terms of frequency of that. And I really like it because it shows you essentially this patient journey along the treatment. So in the clinical development of a drug, such a depiction will help you to understand where do we position new drugs. Where is the unmet need? Like, where does it make sense in terms of the treatment sequence? Sometimes subsequent treatment depends on previous treatment, so you can have a nice visual of how this is working. The other reason why I'm showing this is because it's a fantastic. I really like this sort of new approach of showing data, because essentially it's an interactive way. There's an R-Shiny platform, and you can essentially do subgroup analysis by clicking and changing the tab. So even our marketing people are not very savvy around statistics, etc. They can actually play with the data in real time. And I think that's in terms of the communication bit, I just wanted to put this forward. So we're starting to work towards visualization and also user-friendly sort of visualization. But from what you see now, I think generally it's not that extravagant, and I think you guys are, I'm preaching to the converted. I mean, like, you guys can teach me much more about how we should do that and how we may better depict the different dimensions. So I think that's the sort of overview I wanted to give for you to understand when we use visualizations and why. And really from an analysis perspective, because I think most things could not be done unless you visualize them. This is another example of this. So now just a little bit of challenges overall, my personal view. So why is it not so good? Maybe in our departments, or maybe if you go speak to other people in Roche, they're doing really well, but in the environment that I'm working is not so well. So my experience is that when it's done, when importance is given to data visualization, it's actually done sporadically. So it's not like systematic, top-down, so you need to have proper visualization. I think it's driven by individuals, not even by groups. It's not even the team saying we need to have proper visualization. It's one person saying I can't solve this unless I do it like with a proper visualization, because the particular cross-functional team that I'm working is requesting. I think it's not often done right. What I mean is like comprehensively. You know, you do a nice visualization, but then even with the R-Shiny platforms, often you don't understand what they mean. It's like maybe I have an example here. You know, this stuff no one understands. So in fact, it's nice, and the visualization might not look too bad and so on, but it's still kind of too complex. So I think it's not really done right to be actually really user-friendly. So I'm mentioning language matters because sometimes you don't even explain the data. And I think what the root causes of that, I think primarily is a lack of value recognition. I think people maybe don't realize how important it is maybe at a senior level. Some do, but I would say systematically it's still a bit lacking. I also think one of the reasons is that the benefits are sometimes unclear. So it would help to have clear KPIs. Like if you do it, you're going to be X% better, or X% more efficient. Like this often it says like, well, but they will understand better. Yeah, but can we not do the job anyway? Because nowadays you realize very often people say, you don't have to be excellent. It's 80-20, good enough, it's fine. So you need to really show them, okay, if you do this, much better outcomes going to happen. I also think we have insufficient internal capacity. So all of this together essentially leads to a situation where this is deprioritized relative to other things if you have lack of money or time. I think that's the main reason why. If we want to improve it, then we have to work on these two things, I think. And again, I'm talking here about visualization of complex data for the sake of analysis rather than anything else. But I think you could just wait a bit, and it will come. People will ask for help. Because what's happening is that we have more and more data with increasingly more complex information, and that must be integrated in the future. You will see that, and I want to give you, time-wise I don't know how well we are, but I absolutely have to give you example. So this is not the data visualization, but one of the examples why this is going to be needed is what I mentioned at the beginning, PHC, precision medicine, personalized healthcare. What does it mean? What is it? Essentially, think of a futuristic scenario. In the future, all the data about all the patients will be in a data cloud. And there will be machine learning systems essentially analyzing in real time what are the relevant principal components of patients. How can we differentiate patients? What are the main differences between patients of a particular disease? And then within these components, we will look at how have these patients been treated and what was the outcome of this. So essentially when a patient will come to a clinic or to the doctor, that information cloud will be tapped on. So nowadays we work with treatment guidelines. By the time they're out, they're almost like 10 years of age because you need the time to gather all the scientific evidence, etc. They need to publish this to sort of be integrated in national treatment guidelines. So we're always behind. But in the future, we probably work in real time. I'm not talking about next 10 years, but a bit further down the road. But this is the thing that pharma is working towards. It's like systems that use this machine learning algorithms to tell you essentially this patient belongs to that group, and if that's the favorable outcome for that particular patient, that's the right treatment. And doctors should have access to that information essentially in real time. But how do you do that? I mean, like, this is not just going to be data like what's their age, gender, etc. This is going to be analyzing the whole biome, genome, etc., behavior, comorbidities, etc. So it's going to be a ton of information. And how are you actually going to understand that information and also then visualize the conclusion from it? So currently this is obviously going at such a scale, but more people are experimenting around that and how to do that. And I think that's where we have to develop completely new ways of actually visualizing complex data, because even statistics doesn't have the tools right now to do that, because it's not precedented. It's completely new. Okay, I think that's it. I hope I'm within the time frame, and hopefully if you have questions, feel free to ask. Otherwise, maybe note these questions, maybe more my questions to you. How can you, or how can designers among you maybe help us? What do you, just looking from the examples that I presented, do you have ideas? How can we, people that recognize the issue, sensitize people, create that value recognition internally? And also in terms of those KPIs, it would be interesting to hear about your experience in measuring impact. That's it. I finished my briefing.